Hey class, Absolute5 here. So today we're going to talk furthermore about derivatives, specifically as a function. So what do I mean? By the definition, what is the limit? Well, not a limit, what is the derivative? It's the limit as h approaches 0 of, well, a function f of a, well, f prime of a, is f of a plus h minus f of a all over h. Here, a just means it's at a fixed number, meaning when we want to take the limit or the derivative of this type of value, we want it to just be at a fixed number. But the derivative as a function, so we have our function f prime of x. When this little, like, what do you call this? This little flash, I guess, what do you call it? We call this prime. There's another word to say derivative, which is still the same thing. The limit as h approaches 0, we get f of x plus h minus f of x all over h, where here x is any number that we desire it to be. So that's why it's crucial to understand the difference. One is at a fixed number, x is at any number which we choose to desire, whichever function that we want it to be. So let's do two examples of doing the derivative using this method. Well, this method, not this one, this method, excuse me. So let's do that very carefully and try to understand what are we doing when it comes to doing the derivative. So for example, the example I gave you said, find f prime of x when my function is x to the third minus x. Okay, so again, the limit as h approaches 0 of f of x plus h minus f of x all over h, right? So again, all this is telling you to plug in x plus h wherever you see an x. So let's do that first. So f of x plus h. So we're going to get x plus h to the third minus x plus h. So let's expand this. This is going to be x plus h, x plus h, x plus h. And we get what? X squared plus 2xh plus h squared. How did I get this? X times x, x squared. X times h is xh, and another xh that gives me 2xh. And then I'm left with h times h, h squared. That's how I found this right away. Now, this one's going to be, when you multiply everything out, you're going to get x to the third plus 3xh, x to the third plus 3x squared h plus 3x squared plus h to the third. If you know what Pascal's triangle looks like, that's how you could find this multiplication rather than multiply it out the long way. You could choose either way, but I did it out the long way first time I did it, and it's pretty messy. That's why I recommend doing Pascal's triangle, or just, if you have to, do it the long way. So let's write this to the side so we know when to plug it in again. So we just expanded this entire thing, but this thing's actually, I'm also forgetting minus x plus h on this side. Or really, I'm actually forgetting minus x and minus h because of this thing all the way down here. So let's write all this to the side over here. Let's give it a Pascal for 1 second. So this thing, f of x plus h, x to the third plus 3x squared h plus 3x, sound like I said eggs, x to the third plus 3x squared h plus 3x h squared plus h to the third minus x minus h. So that's this function here. Now for this part, negative f of x is just going to be, for this, it's just going to be negative x to the third minus x, so this becomes negative x to the third plus x. So now when we plug in our entire function, the entire function here, let's see what we get. So still using that, on the upper top corner you see that the limit as h approaches 0, so I'm going to write that first line of f of x plus h, so that's going to be x to the third plus 3x squared h plus 3x h squared plus h to the third minus x minus h. So that's just the first part. The second part is minus f of x, which is just what we already have, which is going to be, put the minus down here, minus x to the third plus h, plus x, over h, I'm getting too excited because this is the best part. You get to cancel stuff out. So we can clearly see that the negative x to the third is going to cancel out with this x to the third. We see this positive x is going to cancel out with this negative x. And we're just going to be left with a whole bunch of h's and x's on top. So I'm going to write that over on this side. Since we exhausted all these information, we don't need to use that anymore. So I'm going to write everything I have in the numerator now. So over here, I get 3x squared h plus 3, let's put lim, as h approaches 0. 3x squared h plus x squared x h squared plus h to the third minus h all over h. We can clearly see that there's an h in every single term, so I'm going to factor out an h. So h parentheses, I get 3x squared plus 3xh plus h squared minus 1. All over h is cancelled, so when I now take the limit as h approaches 0, 3x squared plus 3xh plus h squared plus, minus 1, I'm now going to just plug in h, I'm going to plug in 0 wherever I see an h. So I get 3x squared plus 0 minus 1, or simply f prime of x is equal to 3x squared minus 1, and that is the derivative of this function. Yes, this was a bit tedious, but that's the thing. You have to be very proficient in your algebra to master this stuff here. So be sure to brush up on that stuff. We'll do another one, and it won't be as complicated as this one. We'll do one more. Okay, the next one. So we're going to say find f prime of x when our function is f of x is root x, and we have to find f prime of x. Excuse me. So again, real quick, it's always good to remember the definition right away so you don't forget it. So you write that down first, immediately you know what to plug in. So my f of x plus h is going to be just the root of x plus h, and my f of x is just going to be root x all over my, hold on, sorry. I meant to write that, sorry. So we know f of x plus h is the square root of x. So every student x, you're going to plug in this, so I get this, the square root of x plus h minus the square root of x, which is our function that we began with, over h. Now, if you remember Math 136 or whatever basic math college level that you took, I'm not talking about developmental courses, I'm talking about their first math course. If you remember, what do you do when you have a square root of x plus h minus root x? you have to multiply by its conjugate. So to do that, or essentially when you multiply by the conjugate, you're essentially multiplying by 1, which is funny. Most people won't tell you that. Because that's what the conjugate really is that you're multiplying by 1. Why is it by 1? Because technically, if you divide these two, this whole thing is really 1. But you choose to make 1 to be the conjugate. Anyway, so you multiply. So this goes with this goes with this, and this goes with this, and this goes with that. When I say this, so this times this is going to give me x plus h. It comes out of the radical. And then the middle terms, they cancel out. So we're left with negative root x times positive root x. We get negative x all over the conjugate, which is h times root x plus h plus root x. Don't forget about the limit, right? And we can clearly see the x's will cancel. So I'm left with the limit as h approaches 0 of h all over h parentheses root x plus h plus root x, right? We can see that the h's are going to cancel. So I believe I have enough room to write it on top. So the limit as h approaches 0 of 1 over the square root of x plus h plus the root x. We know this is going to be 0, so I'm left with 1 over root x plus root x. The h disappears here, if you notice that, because we put the 0 in. So I'm left with root x plus root x, which is, there's a 1 in front of each one, so my f of x, well, f prime of x, is going to be 1 over 2 root x. And that's, sorry. And this is my answer. So again, this is a good way to see when you start practicing problems, you need to expose yourself to how do I really use this tool in this way to understand what am I getting. I know it's very confusing at first, but once you've practiced enough, it becomes not too easy, but manageable. That's the best way I could say it, manageable. And I mean, over time, when you get really good at it, then it becomes fairly easy once you become quite skilled at it, some practice. So that's the lesson for you guys. Be sure to like, share, and subscribe to this channel. And if you have a question or you want to leave a comment, be sure to leave it down below. And also, if you like more content, be sure to hit that bell button next to the subscribe button. So this has been Absolute 5. I'm Roger Palomino, and math is infinite because there are infinitely many possibilities. Have an absolutely lovely day.